All right, welcome everyone. Welcome to this new stream. I had to take a short break because of having to do some accounting, but yeah, I'm back now to streaming again, and I finally can do what I planned for the last stream for almost a week now. So today we will be assembling some Hyperram Pmods. So again, a little bit different thing that we will be doing today. It's more of an assembly, manufacturing, production thing. I would love to show you what we will be working on. So there we go. So this is the Hyperram module. This is essentially an extension for the icebreaker to add additional RAM to it. It uses two Pmods. It is a parallel interface which is bidirectional. It has 8 data lines, clock and write and read and chip select. So this is something the interesting thing about this chip is it essentially tries to emulate the ease of use of SRAM chips that are pretty old, and they're easy to use. They are being used quite a lot with FPGAs because of how easy they are. They are not very fast, and they are come in pretty large packages. They are fairly old technology. Cypress came out with Hyperram, which is an emulated SRAM. It has internal automatic update. It's basically a dynamic RAM inside, which is much more modern, and it does the updates automatically internally. But you can access it like an SRAM without having to deal with the updating of the chip itself. Kevin Hubbard, he created the earlier version of those Pmods that are for a single 64 megabit chip. And on basis of this design, because he likes designing stuff just as he calls it, with crayons, so he draws the PCB design without any schematic and just for the fun of it, and he creates those different circuits. And based on his design, which is also available on GitHub, you can see it is on here. I have created our version, the 1-bit squared version of the RAM. It has the same pinout, and it uses, I added additional decoupling capacitors because this is a good practice, and sprinkling some capacitors is always a good idea. If you ask me. So this is what we are making, and we are selling them. They are even in stock because I plan to actually do the manufacturing for bringing them back in stock on my last stream, but that was last week essentially. So I decided to just quickly make a few for the stock, and then come back to do the assembly for singular pieces here on stream. So I will try not to bore you to death with my assembly. So this is what we currently have, but I also created. So this is the circuit that I made in KiCad. It is a 2-layer board. It is pretty simple. It just connects the signals and has the decoupling capacitors. And I use the planes to have ground on the front, and on the back you have the 3.3 volts. Oh, so interesting fact for those chips, there are 2 types of them. There is a 3.3 volt version of them and a 1.8 volt version of them. The 3.3 version is up to 100 megahertz clock speed, and the 1.8 volt version is up to 133 megahertz, as far as I remember. So The problem with that is, though, that you have to also run your FPGA GPIOs at 1.8 volts. It is possible. So on the Icebreaker, we have jumpers, so you can change the GPIO voltage, and you would have to then disconnect here on this board specifically. If you use this design, you would have to disconnect the 3.3 volts. So it is possible, but it is a little bit fiddly to convert it to 1.8 volts to gain more speed. That said, it is not super useful for the Icebreaker itself, because the GPIO speed also taps out almost around the 100 megahertz range. So it is not such a huge gain for us to actually use the 1.8 volt versions of these Pmods on the Icebreaker. But there are other boards like the ULX, which is an ECP5 board, or Orange Crab that is coming up, where the 1.8 volt version would work, and you actually would be able to use the speed of those chips. So based on that design, because I had to make new batch of the boards, I decided, well, if I'm already making a new batch, why not make it yak shaving session and make a better version of the Pmod? So when you look at the pinout here, there are some pins. So let me go to the schematic that is clear, I think, in here. So in the schematic, you can see we have unused pins. There's this pin. I started poking at it. Anyways, so chip select here is also not connected on the single Pmod. I think I started poking on this design, but there are several pins on the Pmods that were unused. There were 3 of them unused. So that means we can use additional chip selects and drive up to 4 Hyperram chips. So if I open the new design, open recent, and the quad Hyperram, I created this guy, which is a 4-layer board, because we are running out of space in this space. So it is nicer to have the planes more continuous. So I put the power planes on the inside of the board. But it essentially allows us to drive additional GPIO. To clean up the signal connections, I also reorganized the pin connections. This allows us to do some length matching and make it a straighter connection. So that's one of the bigger improvements, is at least from the Pmod connectors to the chips, we have length matching. So how this works is the signals go all the way down to the board and then connect through into the chips. So they are essentially in a string. So we have a nice bus of those Hyperram chips. And what I also added, which we are not using today, not on this board, because we are using the 3.3 volt version of the chips, but I still added the footprint to add a 1.8 volt voltage regulator. This makes it easier that you don't have to rewire your Pmods to 1.8 volts on your FPGA. So you can just supply it with 3.3 volts, change the jumper here on the back, and use this 1.8 voltage regulator to step it down, to power the chips. And all then you need to do is to change the GPIO voltage of your FPGA board, which usually is easier than changing the power supply for the Pmods. Okay, so these are the 2 boards we will be working on today. So let me show you here under the microscope. We have the 2 boards. So this is nice and wonderful Oshpark PCBs, nice and purple. So this is the one board, and you see we have all these traces on the outside, and they are connected. That's the one. This is the 2-layer board. And here's the new 4-chip board. Yeah, there you go. So you see most of the connections are actually on the back, and nice meandering traces. So the ones that are on the lower Pmod have those meanders that extend the length of those wires, so that the length from this hole here is essentially the same one as from the others. I didn't match all the signals. I only matched the ones that matter. For example, reset doesn't need to be length matched. It's not a time critical connection, but and I think chip select is also not really necessary, but definitely clock and the data lines, they're all matched. And I used this really awesome script for KiCad from Greg DeVille. He made for, I think he used it on the Orange Crab. And he made this script that is, you can put in which chip so which chip should the length matcher look at, and those connections, and measure from those pads all the way to which other component. So we can essentially say, please only measure the distance between the last chip on the Pmod and the Pmod connections, and give me those lengths, and it automatically runs in the background. When I save the KiCad board file, it automatically detects it, calculates the lengths again, and shows me even color-coded red, green, what the length matching is. And this was after getting that script running in a separate window, and I popped it on top, and the process is really fast then to like iterate until you get those lengths all completely correctly matched. So it was a fairly good process thanks to that. Still, I'm really looking forward to have multi-signal length matching tools built into KiCad itself, where you can use those meander expansion contraction tools, and those being improved over time to make this process even better. But it's definitely possible to do length matching on on complete buses, which is really cool. Okay, so what we need to do now is look here at the desktop. So I have solder paste, I have my spatula, I have my squeegees for the solder paste. I also have, let me look at this here. So this is the stencil. Let's see. I will need to do some adjustment here. So this is how I usually do this. I also use some tweezers. Let me get some tweezers because that makes my life easier. So yeah, you can just open it up and close. And I have a loop to adjust things. So this is glued just directly to the table. I use the Osh stencil brackets that you can buy them. This is like just laser cut acrylic, and it is pretty much exactly 1.6 millimeter thick. So the PCBs are flush with it. So you don't even have to have a huge stash of extra PCBs to jig this together. But you could, if you have spare PCBs, you can build a jig like that yourself. I used this before, but it got misaligned. I had to remove a PCB. So anyways, I need to redo the alignment. And we just press this here in, if this fits. This is not really fitting, so maybe I need to, either I need to adjust. So when they come from Oshpark, they have those tabs. I did file them down already. It should actually fit. There we go. And now we can use this spare PCB because that's something I didn't have available. There we go. Use this black magic probe here, PCB, to just keep this as a stop, and then we can remove it from the corner here or use tweezers to even leverage it out. And now we need to take the stencil, and I can see it from the top. Maybe you can see it too. Let's see. Let's do this. Yeah, that's good. And then let's zoom in. Yeah, that will be nice. There we go. So let's see. Where are the pads there? Trying to find where the... Oh, this is upside down. There you go. Actually, I want it this way. That's better. There we go. So I just, it's pretty easy to see when the golden pads appear and disappear. And you get really pretty good alignment already without even any magnification. But just to make sure, that's not, there we go. The light is coming from an angle here at the moment, so I see a little bit of a shadow, but otherwise it's looking good. All right, it's not, doesn't have to be super perfect, but it should be fairly accurate. Yeah, let's see, can I bring you even tighter to this? This way, this way, this way. It's a little bit awkward because will that zoom in? I think we are too close now for this camera. Let's see. There we go. Yeah, so it should be good enough. So if I press down, you see the pads appear. And yeah, that's it. Now it is nicely aligned. I don't have any aperture shrinking here. So, oh, Timon, welcome. Welcome to the chat. So yeah, now the next step, so I should probably get you out of the zoom again, is getting the solder paste out of my, let's do this, out of the container. Tuk tuk. All right, so now let's open this up. There we go. Nice gray peanut butter. A little bit stir to even out moisture levels. This is something I'm not using very much of it, so not today at least. It's not a big manufacturing run. The fun thing is, what it reminds me of is seeing those proper PCB assembly lines that use stencil printers. They actually have a cartridge in the back, which looks like a big syringe. And they dispense a small amount of solder paste every few cycles to add to the solder paste so that it doesn't dry out. So it automatically controls it. And also inside, they don't really have environmental control regarding the moisture and temperature inside, but they do monitor what it is. So they see what the situation is. At least that's Screaming Circuits, that's what they told me. You see the humidity sensor in there and temperature sensor. But they still the difference between summer and winter and how moist it is outside, you do see variation in the manufacturing reliability. Even I see that when I'm doing manufacturing, especially because I use my ovens on the front porch. So I do this. Oh, I'm sorry. Let me show that to you. So just spread it on the squeegees. And now I have a nice bead like this. And now I can just put it down. And whoop. And now we just open it up. And I can remove it. There you go. Now let's look under the microscope how it looks. Switch to the microscope view. Yeah, it's not perfect. That doesn't have to be, but it's close enough. I can try to do a better job and readjust it for the next board. So let's make 3 of those. That should be easy enough. I usually don't like making just one board at a time. I rather do like a few boards. So 2 or 3. 3 is usually the comfortable area where I like making things. Same things with the, well, panels is different because when I have panels, then I do it on the pick and place machine. Okay. Oh, I did it upside down again. Come on. No, it's not a good technique. I don't like putting this splorch on the stencil. I don't get even distribution of the bead. This way you have really good control and you don't have voiding inside the solder paste. So the problem with just putting a bead down and then squeegeeing it over, it results in having voids inside the solder paste. So it is much more likely to not hit an area. Also, I've seen several people to like go ham on like squeegeeing it over and then squeegeeing 50 times until they like get everything off. That just squeezes solder paste under the stencil and results in a huge mess on the pads. It's like I've seen several YouTubers do this, and it just makes me cringe. Oh yeah, several times. Don't do that. One squeegee. It works twice if you have a very controlled angle on a machine that does the squeegeeing. I've seen several people recommend on like YouTubes and other tutorials to, oh, just squeegee it over and then go the second time to remove the excess. Please don't do that. That's a terrible idea. If there is any slack. What do you mean with slack? I don't understand. So let's readjust it. As we saw, we were tiny amount off, and let's be perfect on this. So I will put an eye on. And now we'll try, because now I don't have the camera in the way as much. And there we go. Hopefully that's better. I might need to improve my Kapton tape here, but that's okay. Again, in this board, it's not a huge problem to have a little bit misalignment. Let me redo the bead. And once, and distribute nicely, have a nice bead, and then whoop, and open. Let's see if that worked better. It's still a tiny bit off, but that's totally fine. This is totally within tolerance. Okay, let's take a third one. And I will read Timon's comment in a second. Let's do the last one here. There we go. And open. Come on. There we go. Yeah, see, this is pretty much perfect. That went perfect. Yeah, very nice definition of the solder paste. We can, yeah, we will need to, I will put this away. I usually keep the solder paste on the spatula and put like a cover over it so that it doesn't evaporate too much. But here I will just put it back because we will do the 4 Hyperram ones next. There we go. I will finish the rest of the batch off stream. There we go. Let's close this up. Close this up. Okay, so let's see. Well, okay, so Timon is saying that if there's any slack in the z-axis, it becomes a problem. So this is why, so there's several things to say about this. One is the setup this is actually not that critical depending on the type of board. So if it is a, so get stencils from Osh Stencil, don't get the Chinese ones because they're always bent. So they are just terrible and it's very annoying. So first of all, get decent quality stencils instead of junk. Second of all, if you have height differences on the, like between the PCB and your jig setup, that does happen, you can compensate for that. You can still, it's basically you feel it, you can do one pass, open it up, check the board. If this doesn't really work, rather remove the solder paste from that board and redo it again. It's like, this is usually not a huge problem to do. And then you can basically feel that you need to adjust the heights. You can shim the heights a little bit. I don't usually need to do that. The boards or the stencil, the heights are usually quite okay. So this is how I would approach this. I would rather change all the other parameters and still squeegee only once than having to scrape the second time. I rarely, sometimes but rarely do that, and pretty much every time I regret it because having the so if you do the second pass, you even end up with removing too much solder paste from the pads, as well as squeezing it under the stencil. So you have like two negatives that come together. So that's why I'm advocating for the single pass approach. this two-pass approach, which the stencil printers use, is only possible because they have a very tight control over the pressure, speed, and angle, which as a human, I don't have that. Maybe over time you can develop it, just like a knife grinder person that can really get the angle of the blade right to grind the correct sharp edge. But for hobby use, I think it's like we can't expect to have the perfect control every time. So yeah, that's my take on this. Again, your mileage might vary. If that, as always, if the other technique works for you and you get good results for it, perfect. That's great. No criticism. It's just I've seen this work for me better, and I've seen a few times people use the other technique with bad results, then switching to my technique and it worked better. So I've seen some data on that end. So I don't know. Ask 5 people, you get 5 answers, I guess. Yeah. Well, it takes time, I think, to get this right. I just take my time, and also I have to regularly tell myself, it's like, remove the solder paste from the board again. Don't just reflow it the way it is, because you will regret the amount of rework you will have later. And it's, yeah, it does sometimes happen. It's like, I'm rushing it, I don't have time to redo it, so then I regret it. So yeah. Okay, so now we have those 3 boards. Let's clean up here. So I'm using, to clean up my my boards, I use the stencil wipes, the IPA cleaning wipes. They are really awesome from Tech Spray. So they are very nice, dense tissues that are don't lose the fibers, so they're very nice, and they are IPA filled, and you just can wipe this nicely. I even tap it sometimes a little bit to squeeze it through the holes and clean it. So that's another thing that I had to learn the hard way. So usually when I do full stencils, I clean the stencil every second application of solder paste, or even every single time if this is a very fine board, because you still get a little bit of flux and buildup around the stencil on the bottom side. So if you make a bunch of boards, is really worth taking the time to clean the stencil, and you just need to clean it on the back. You don't really need to clean the top. You just wipe it on with the IPA wipes on the bottom to push the stuff in and remove any solder paste that or flux that might build up on the bottom side that will create variability. Just remove it and close it, and then you can squeegee again. You don't really need to clean the top if you are doing a batch. So that's my solution for that. Yeah, reworking 200. Yeah, I had a lot of fun when I made a tiny micro badge for Joe Fitz for securing hardware. This was a super dense board and very thin, and there were so many pads on it, and applying solder paste equally on this was not easy. And then I still had to rework stuff for multiple reasons. Like the pad design was not perfect, then the placing of all those parts on there. It really depends on the board, and the more difficult the board, the more time it takes to actually get the process sorted out and understood. But it is a learning experience, so no complaints there. I definitely learned a bunch doing that. So yeah. Okay, so now that is clean, so that it won't dry on. So the next thing is, let's put the, let's put the Hyperrams on first. So this is what the Hyperrams come in. This is a tray. Not everyone knows what that is. It's a tray of chips. Let's do this. So instead of coming on a reel, they come on this rack, and I just tape it together with some blue tape so that it doesn't fall out. Let's see if we make a huge mess or not. Hopefully not. Maybe there are some special clips that you can clip on the sides of the trays to store it so that it is not an easier process. I need a 3D printer right now. I need to prototype some things. All right, so that's it. Now we can open this. There you go. And these are the chips. Here they go. And I'm using these pretty coarse tweezers because these are big chips. And all I need to do is pick one up. Let's switch to the microscope. Zoom out a little bit. I don't want to smudge things. Let's see what my caffeination level is, how shaky I am. Well, it looks pretty good. So I'm using the second finger to control, to have on the, so if you look here, I hold my finger on the tweezers to basically add stability to what I'm doing. And all I need to do is align this with the outer markers and drop it. Even a few tries will work. Then I nudge it into position. There we go. And you see this is actually gluing itself to the PCB using the tension of the solder paste, which is nice. So that's one. Let's do it 2 times more. Polish wipes, same stuff, but not pre-soaked with IPA, then spray with IPA beforehand. Interesting. Yeah, that might be a solution, but I'm buying them in bulk, in cartridges like this. So I get like a full roll of these. And I buy usually a full set of 8 of those packages, because I go through them fairly quickly. What is Cetus 3D? Get a Cetus 3D. What is Cetus 3D? Let me look it up. Oh, great. Now I made a mess. Ah, superb. That's what is dangerous with trays. You can make a mess really quickly because they love to jump out with the slightest bump. All right, they're back. Perfect. A 3D printer. Yeah, no, I'm getting a Prusa. I'm not getting a Cetus. I know it's a good printer. I've seen it in action. Several friends have the Prusas, and they just work out of the box. I don't need a project if I'm buying a 3D printer. I want something that definitely works out of the box with the standard settings. I already have enough projects. That's my take. And I think Prusa also deserves to So the reason is I really need. I also feel like Prusa as the company really deserves to get money for their work. The approach to the community and the open sourceness and how they make things is really commendable. I do think that they do it very well and the right way, and so I also, this is another reason to get it is to just support the effort of Prusa. So that's what I will do when I get a 3D printer. All right, so that's done. That was fairly quick. Now let's get the oh, I should close this so that I don't make a mess, obviously. Yeah, the 3D printer community has a lot of opinions about their printers. So I don't really want to start a brand war here. There we go. So these are the 100 nanofarad capacitors. Let's put those on. No, not the right tweezers. These tweezers are annoying for this kind of work. There we go. 1, 2, and 3. There we go. That's 1. Now let's do this. One. 2. And 3. Yeah. Yeah, it's like the people in the 3D printer stuff, they take, so this is the nice thing about Prusa. They do publish this stuff and people then take it and make cheaper or better or different clones or copies of them. And then I think Prusa also like incorporates their changes into their design. But what's nice about Prusa is the fact that they really eat their dog food. So they build the parts for their own printers using their own printers, which is pretty crazy, to be honest, but it works out for them, which is nice. I think there's several others that do 3D print their own parts for the printers. I'm pretty sure there are others. I'm just blanking on the name now. Oh, that's cool. That's nice that you can disassemble and assemble it again without losing calibration. That's nice. I'm sure the Cetus is a good printer. I believe you. All right, so now we will do something that I don't usually assemble this way. So I usually reflow in a reflow oven, but for this time, I was thinking we will reflow those boards using a heat plate so that we can be here and see how it is happening. So I will use a hot plate. It is a fairly cheap reflow solution. It's this thing. Let's see if we can see the temperature in here without making a huge mess. There we go. So I will heat it from the bottom using the heat plate, and then use my rework hot air thing. Hi, reporting. Welcome to the stream. Thank you for joining. If I used the Inspect AR tool to assembling larger boards. So I have not. It only makes sense if you... so for me, I'm doing a lot of the prototype assembly using the microscope, and I don't have a way of projecting the AR stuff into my microscope. So fiddling with my phone over the board every time I'm doing things is not very good solution. So what I actually use is the web export. So so let me show you here really quick. This is still heating, so let's let it heat. It's like, yeah, this has to go up to 260 degrees. It's at 132 now. So we have a moment. So if we go to the desktop, there's this button here, which is Generate Interactive HTML BOM. It's a plugin for KiCad, and this is what I use. I have to icebreaker Pmod git. I think that's generate BOM. I'm not sure because I had issues with this not opening in the right browser. Oh yeah, there we go. So it's opening here, that's fine. So it automatically opens in the browser and you get this. So you can see which parts are where on the right side, and you can select if you want to see it this way. And then you have the back side, which is, yeah, so this is what I use for assembly. This is really good tool. I use it a lot, and then I can say placed or sourced, and then really cross off things. This is my my go-to solution. Oh, and you can even save stuff by now. These are new features. I have not seen this before. And then also get the board stats. That's very nice. Yeah, so this is what I use. I love this tool. This is really good. Also, it's so easy to use. You just open KiCad, press on that damn button, and then it just opens. It can't be easier than that. That's what I use for assembly. Inspect AR is pretty nice. If there was a way of overlaying the video into the microscope, then it would be useful. And it had like maybe an iPad to control it, where you can choose which item you are assembling now, and then it would show you on the PCB where to put it. That would be very useful. And I did write that to the Inspect AR people as a suggestion that this would be a real solid use case for their tool, is actually having it as part of a microscope and having some controls for it. I would love to see that. For now, having a microscope and using the computer monitor on the same desk where you do assembly and go through the things, that works great. But yeah, they are still a young startup. They are working their way through all the features, and I'm really curious where they will get. Yeah, if you are okay with not having stereoscopic vision, and you are assembling stuff through a monitor, it's like the problem for me is not just the lack of stereoscopic vision when you use the camera and have a monitor, it's also the lag. like having this lag is really throwing me off. So it has to be subframed. It's like you want defined control over your fingers and over what you're doing. So that was the reason why I have the optical microscope with the camera on it. But yeah, what I would love to is, if you do that, you either have like a stereoscopic goggles on this with overlay AR, or you have optically it aligned on top. There are many solutions to this, I'm sure. I'm not sure there's any, well, I'm not sure which solution is. Definitely feeding it through the video and adding AR and putting it on a monitor is the most affordable one, which probably could be done now fairly easily. But everything else requires some optical hardware, which is very expensive usually. But yeah, I would love to see what people come up with. All right, so this is heated up. I will put the boards on here. 1 and 2 and 3. Let's zoom in here. I don't want to toast my camera. There we go. This is the lag on my camera. This is very annoying. This is what I'm talking about. I hate lag. Yeah, all right. So, yeah, it's already reflowing. Well, that was pretty easy. Just equalizing it a little bit. Oops, sorry, I'm totally in your view. But yeah, it basically just reflowed. It's really difficult to, I need more light. Oh, so by the way, I'm getting light strips for the table up there. So, and I got some nice UE LED strips, which are really high CRI, so they will be very pretty on video, I hope. Oh, it's... Yeah, that's another rabbit hole I went into. I started looking at white LEDs and learning about this video rendering index, which is which is a separate thing from color rendering index, because CRI is for your eyes, the other one is for cameras. So yeah, I learned something. TSRI, some television something rendering index. Yeah, but it's a separate metric. Okay, so I think that's good enough. I can just pull them off by the hose and just put them somewhere. Here. It's not a bent this stencil. It's a silly idea. Let's put it here. There we go. And 2. And 3. Okay, now we can inspect them. So I can switch this guy off for now. Let's not burn my foot, but still, let's put it away. Be careful with the cables. Okie dokie. Let's see how that worked out. Yeah, so they are nicely seated. I'm not sure, is it visible? Yeah. See microscope there. Let's see. Yeah, you can see between the balls. They are nicely smooshed and reflown. Yeah, they are. Was easy. Same thing here, let's see. There we go. Yeah. So that looks good. No shorts. Yeah. Now this is Sylvain was asking me. It's like, oh, you are adding solder paste. You are not just using flux to reflow these. Yeah. If I just use flux and don't add any solder paste to the pads of the VGA, there would be barely any gap. They would be completely smooshed onto the board. And also, the Hyperram boards chips, because they have this uneven pattern. Like, let me show you here. Yeah. So they have this one ball missing there, and then you have like also some grounding. If you have multiple pins connected to a pad, you have differentiation in thermal. They sit also crooked afterwards, so I don't really like that. So I rather add solder paste and be careful with it, and then you have at least a little bit of a elevation in here, so that you can inspect it easier. So let's inspect this guy. That looks good. You also have light. So, oh yeah, that's another thing that people are recommending. Just use a light. Let's see. Can we do this? Is it bright enough? I don't have a good angle for this. Oh, there we go. Yeah. You can see through here. There we go. Yeah, you can see between the balls. There we go. That's cool. That's the second one and the third one. This way. Yeah, this light is not perfect. Yeah, there we go. Nice separated balls. Looking good. Okay. So the next step is obviously put the pin headers on this, but yeah, so let's solder the pin headers on and then test them really quick. And then we can move on to the 4X boards. For that, we are using this exhaust and a soldering iron. This one needs some trimming. There we go. That's one. These look good. Okay, so now 1 and 2. Okay. So just focus here. One. Just to tack them into place. And then I use finger to adjust it. Oh, I started on the wrong pin. I think this camera is not pointing in the right direction. Let's see. There we go. There we go. So that you see a little bit what I'm poking on here. just holding with my finger against the board so that it becomes square with the plastic. I should be doing it on the other row, not burn myself. I can do that on the other board. Okay, so that's that. Come on. So yeah, the ones that are connected to the ground plane are always more painful to reflow. There we go. There we go. That's done. Now 2 more to go. One and 2. So I should be doing it on this side, because then I don't burn myself when I'm aligning them. Decrease the probability of burning myself. There we go. 1, 2. Now here. 1. And 2. Align. Now we can solder them. There we go. The other side. Yeah, so this is soldering those connectors is a really time-consuming part that I rather not do. I can do it for prototypes, and I offer it for a few of the adapters to do by hand as an extra cost, but I don't like doing this. It's also very time consuming. So my resolution for this year is to assemble more stuff at a CM. So one of the things I will probably be doing is make more of these small simple boards at a CM. Of course, depending on the quantity, because not everything is big enough quantity to warrant setting everything up and sending parts across continents, or dealing with third parties to deal with this. So not everything I will do that way, but several things I was thinking I will order in a bigger quantity, and hopefully they will sell over time. So yeah, that's number 2. And number 3. This one is missing a pin, so that's going on the trash pile. That's another weird one. Missing a leg. This is a weird set of connectors. Okay, that should work. Oh, there's another one. I think I got them. Curious where they came from, this set of connectors. They look very hand cut. Okie-dokie. Is this cooled down finally? It's like I smell the hot plate up here, but it's still cooling down. That's why. I'm afraid of burning myself on it. 260 degrees C is no joke. Okay. Let's sort it down. Then we can get to testing. So for testing, I am using this script that I think Matt Venn developed a long time ago. It's using Kevin Hubbard's Hyperram interface implementation in Verilog. And then over serial, it can write and read bytes using a Python script. So that's what I'm still using on the single Hyperram modules. It would be nice. Yeah, and then Sylvain took that design and implemented a much better one and faster, but I'm not sure. I think it has some testing capability, but we will see on the 4-pin Hyperram modules in a bit. I did not have time to study it in detail, how it works, so that I can switch over to using something more unified and faster that can test it. So you will see in a minute how that script runs on this board. There we go. Okay, that's done. It's all 3 done. Now, let's switch over to the PC desktop and switch over to the terminal. So where are we? Yeah, there we are. So here is the icebreaker. Icebreaker. And we have this tool here, icebreaker example, that is in my clone. So let me show you where to find it if you ever want to play with this. So that's my current setup. GitHub, Esden, Hyperram, and then the branch is icebreaker example. So that's the code. Let me check. Yeah, that was Matt Van. He did that. The changes necessary to do the testing. So this is the branch that you would need if you want to reproduce what I did. And then I programmed the icebreaker, and now I can plug in the Hyperram Pmod like this. Let's do this. There we go. And now /control, just run it. Let's hope for the best. So it is blinking, so it is definitely counting through the addresses already. And then it shows that, so if this runs like this, then it is successful. It can show you what happens when things go wrong. You got failures like this. So yeah, if you don't get failures, then you're good and the connection is good. So that takes a while. Let me restart this and run it from the top. So yeah, this will run for a bit. Yeah, and when it is done, then we will see that this module is working. So let me put that to the side. And it takes quite a while. It takes like 5 minutes or something to run through the whole memory. So now we can start preparing for the 4x Hyperram modules. So one thing to be said about this, you can just populate less of the Hyperrams chips on this. So I am hoping that down the road I can just replace the single ones also with this board, and basically just use the same board and order it in bulk, and then populate either 1, maybe 2, and maybe 4. It's like making 4 SKUs seems a little bit silly, so I will be probably making a single, dual, and quad version of this Hyperram module. I think that makes most sense. So you get a lot of additional memory. So let's see that this finishes, hopefully, soon. So it is essentially writing bytes to the memory and then reading it out and making sure that it works correctly. Okay, well, I don't really want to wait that long. All right, so I will let you know if it finishes or not. So let's go to the desktop. So here we will now set up the second stencil. Let me zoom out. There we go. So here I have the stencil for the 4x Hyperrams. Is that visible? So yeah, our stencil. I really like those guys. They make really nice stencils and they don't cost too much. They are very affordable. It's not the $10 you get from China, but those stencils bit me in the butt so many times that I don't even bother anymore. It's not worth my time and my nerves. And then I have to buy them again anyways. So it's like from our stencil. So why waste $10 if I can put them towards a proper stencil? And there we go. Removed. Let me put that backing away. That is much bigger. I think I might have added some margin here. That will be interesting. Let's do this. Oh, let me focus here, because this is not really focused. There we go, that's better. Bam. Is that the correct orientation? I think it is. There we go. Huh. Oh, it is not. Interesting. This way. Upside down. Nice. There we go. Get my eye. Ah, I should have taken some tape, shouldn't I? There you go. Let me get scissors. Yeah, I should probably change the jigging here so that I have a better surface to support the hinge for the stencil. But yeah, let's see if that works out. There we go. Come on. There we go. So it's only hinged here on the center. So it's not ideal, but it's something. Yeah, I should probably have this rotated somehow and have the have this hinged nicer. It's not a huge deal, I hope. We'll see. We'll see how much of a deal it is when we do it. Okay. Let's get some mix. There we go. So just to clarify, so what are the squeegees made of? This is actually stencil material. So there's this company called Stencils Unlimited, I think, and they were the company I ordered stencils from in the past. They are very expensive though, so they were much more expensive than Osh stencils, and that's why. And they were sending you a full kit with a stencil and a squeegee that is exactly the width of the board that you need. So this is essentially just cut out of a little bit thicker stencil material, and that's pretty much it. And it has the. Yeah, it works really well, I feel. I really like those. And I just attached some plywood. This is just the backing material from PCBs, from the drilling process, as you can see. So this is something that you get when you order PCBs. They often come backed by this MDF material. Okay, let's try it. And open. We're not putting the voltage regulator on, but that doesn't matter. It will just reflow on its own. There we go. It's looking pretty good. That's good alignment, I feel. Yeah? What do you guys think? Looks good. Let's do... Should we do all three? Should we risk it? Or should I just assemble one first? I know that the circuit does work. Blockchain? No. Definitely not. Like, I'm not sure why you're coming to such a conclusion. Yeah. I'm not sure so I know that Sylvain used this design. He ordered his own boards and he tested it. So I know that the hardware design at least works. I should probably do some beeping out to make sure that there are no opens or shorts on this on the etching of these boards. But I didn't do that. I already put this solder paste on, and I don't really want to bore you guys with me beeping things out. So yeah, let's make a compromise. Let's assemble two of them, or maybe let's assemble one. Trying to have a good decision. This is not a hardware wallet. This is just electronics. This is for prototyping FPGAs. So this is a plugin that goes into the Icebreaker FPGA development board to extend memory on this. So this is something for if you want to learn how to develop FPGA designs and digital design. So this is an accessory for that. And essentially those hardware wallets are just iPhones, so, or it's cell phones, so it's not really anything else. So it is still electronics, so you're not that far off, even though the application is different here. Okay, so what do I decide to do? I think I should just risk it and do at least two of them. The third one I can assemble later off stream. There we go. Squeegee on, wax off. There we go. Ugh, I made a mess. How much of a mess did I make? Yeah, this has to be redone. It flipped in my fingers. Okay, so let's get the wiper. It's pretty easy. As I said, rather remove the solder paste than this. This looks always pretty cool. It's like the whole design ends up on the tissue. There we go. All right, so that's cleaned. Let's redo it. To be fair, there is a project that Bunny Huang and Zobs, Sean Cross, are working on. It is a secure enclave processor, so regarding the Bitcoin wallet or whatever you want to call it. There is a project that is using the same FPGA for prototyping purposes as we have on here. So let me find that, because that's actually quite an interesting project. I just don't remember what it was. Secure enclave. Be trusted. There we go. That's it. That's what it is. This is a very interesting project that they are working on. There. So that's Be Trusted. This is something Bunny and Zobs are working on. There is a talk at CCC about hardware security. Let's see. 36C3, I think. That was his. Open source is insufficient to solve trust problems. That's his talk. It's a very interesting talk. I can highly recommend watching that, because it's not just approaching the problems of security with just, oh, we just do it this way and it is solved. And he really looks at the whole ecosystem and the whole problem in general, and tries to find a best compromise to come with a good solution. So yeah, Bunny knows what he's talking about. That's my take on this. And yeah, this is a very interesting talk that he did last December, or only 2 months ago. So it's CCC. So I can really recommend that talk if you are interested in security and hardware security. This is interesting stuff. Okay, microscope. Let's go back. Let's assemble these. Let's put the solder paste back into the container though. Come on. There we go. Just to squeeze the lid in. Yeah, I need a better hinging solution for this stencil. Dimensions don't work perfectly, but that's just for prototyping. I need to switch to full panels of these RAM boards. I was surprised how many people actually were interested in the in the Hyperrams as soon as I put them back in stock. There was obviously some pent-up demand, which is nice. Always nice to see. And I really appreciate it. It does support things we do here. There we go. Now, let's move this out of the way. Let's keep some order with things. Okay, where was I? I need the Hyperram chips. This eats up a bunch. Oh yeah, I wanted to also check what the... Yeah, so this one finished. So this is how it looks when... PC desktop. There we go. So this is how it looks when it actually finishes testing a board. Let's do that for board number 2. Up. There we go. Board number 2. And then we can test the last one. Yeah, I have a few more here to assemble. I can do that off stream and put them back in stock. There we go. Hyperrams. Let's populate this puppy. We have, oh yeah, we should switch back to microscope view. There we go. Let's set the proper focus for you. There we go. All right. There. There we go. I think that's good. It's less tacky than the previous run. Up. There we go. Come on. Stay on your pads. 2. 3. So you might be asking why there are these whiskers on those pads. So here, if you see, there are these short tracks that go out of the pad. They are not connecting to anything. This is just for me to equalize the heat distribution when I reflow the board, so that each pad has a little bit closer to each other's thermal capacity, so that one doesn't reflow earlier than the other. Trying at least. I'm sure it is not ideal and it would require a little bit more testing, but that is the thought behind it. Yep. There we go. Come on. Stop scooting around. Okay, so that's one. Now let's do the other board. There we go. 1. Right, that's a very good point. So Sylvain is pointing out that these whiskers help to keep the pads on the board. Yes, that's definitely true. These pads are tiny, so the surface area of the bonding is... Let me deal with this really quick. There we go, better. I'm still filtering out of that playlist all the vocal tracks. I'm sorry about that. Okay, yeah, so basically these pads are very tiny, so the bonding surface to the substrate is very small. So this is increasing it and also adding like retention through the solder stop. So that improves the situation there. And also welcome Sylvain to the stream. I have not heard from you earlier. I guess you were busy. I hope your evening is going well. There we go. 2. 3. Oh, come on. Oh, super shaky. I think I need lunch. That's what's going on. But we are almost done for today. Just one more BGA to place. There we go. Perfection. All right. So that's nice. Now, let's put this away before we lose it all over the floor. There we go. No floor for you today. Okay. All right. Oh, I can test the last one. Just test the last Hyperram on here. It's looking good so far. Now let's get some 10 microfarad, 100 nanofarad capacitors. Need a little bit more on this board. And we'll put them on the desk like that. Oh, thank you for subscribing, Scott. Welcome. Thank you for your subscription. Or I mean notification. It's nice to see you. Oh, Sedacious, thank you for your subscription. I appreciate it. I need my tweezers, my small tweezers, my fine tweezers. Oh, I wanted to... Oh, welcome, 126 Tech. And hello. Oh, Sedacious, you subscribed to Twitch Prime. Thank you so much. You're the first. I really appreciate that. I can... I can give the sub to Sylvain. I'm not sure how this works. I'm still learning how this whole Twitch thing works. Those chats are weird. I don't know. That doesn't make sense. But anyways, all right. Oh, thank you very much. Yeah, I'm glad you like it. Yeah, it's like this is not the worst. It's like especially these BGAs, they are 0.8 millimeter pitch. And they don't have too many balls. So far, knock on wood, I didn't have too many problems. We will see with these boards because these are new. But I hope it will be easy. And you will see in a minute that I will be using a different approach. I also use usually an oven for prototyping as well as manufacturing of our products. But in this stream I will actually use a hot plate instead, because then I don't have to run out up front and it's easier to see how it works. I still don't have a macro lens for, I think I will have to do something about that. For the desk camera, I don't have a macro view, so I can't just zoom in onto the hot plate so that you can see how the pads reflow on the parts. That would be very nice to see, but maybe in one of the future streams I will have that set up so that you can see that more accurately. So these are all 402 capacitors, decoupling capacitors for the power supplies rails of this Hyperram chip. And we will populate also a 10 microfarad capacitor, a big one, on the main supply rail, just to be nice to our rail voltages, rail supplies. Well, you will see also, it's like in a moment, you can actually verify the VGA pins. You can see between the legs and see if you have shorts or not, and if the pins are connected. So yeah, BGA, the rework capability. So you have to, I think the main thing is that your reflow and solder or solder paste dispense is accurate. You don't have too much or too little solder paste on your pads, and figure that out with simpler designs first, where you can rework things, and then you can definitely move on to BGAs. They are not, so far from what I've seen, they are not really much harder than, well, it's all very relative. It really depends. It's like I've seen people struggle with really oh, you got yours from Kevin. Yeah. Yeah, they are being sold. They are already, so the single Hyperram modules, they're already available on the 1bit2 store. So you can just buy them. Just look at 1bit2.com. I showed it earlier here. Yeah, they're already in stock. Let's see. Over here. There. So yeah, they are available. This is the single Hyperram module. The quad Hyperrams, I am now prototyping. I'm building the prototypes to test them. If they work out, I will order more PCBs and put them in the store too. Yeah, let's go back to the microscope. Yeah, I'm glad you like it. Yeah. Trying to make things available to the community so that you can build awesome stuff. Don't get me wrong, like learning how to reflow BGAs and assemble stuff is very useful skill to have. Building electronics is a very, very fun thing to do, with a pretty nice reward of you have actually the physical thing that you built yourself in your hand. It's very nice. A lot of capacitors on these boards. Still not enough, wow. And I pulled out a bunch out of the box. Out of my magic box. 3 more. 1, 2, and 3. So now I have to check which one of the two capacitors on the input rail is the one we will be populating. Because I think it is this one. This is the 3.3 volt one, I think. But we can just check. As I showed you before, you can go on here and just press this button in KiCad, generate BOM, and there we go. So which one is the, oh yeah, I should actually check it also in the, yeah, so this is the one that with 3.3 volts, but we can also see it here, which ones are the 470 pico, and this is the 4.7 microfarad. 4.7 micro. I thought I put 10. Oh no, they are 4.7. So these are the tank capacitors for yeah, it is a huge time saver for prototyping to have a box with just parts. That's a very good point. Sedacious, that's, I agree. Yeah, so Sylvain is saying these boards work without capacitors. I totally can believe that. It is just me being overzealous with like making sure this this works 100%. So yeah, let's go back to the microscope. It's jumping between the scenes. But yeah, there we go. So let's put this guy on. One. Oh, come on. Some fluff on my tweezers. There we go. 1 and 2. And we are done. So we are not populating the voltage regulator, as I said before, because this is 3.3 volt chips. You only need this voltage regulator if you're using 1.8 volt voltage chip type, which is faster, but we don't need it for the icebreaker, and so on and so forth. If they're in the VOD, you can go back and then watch me explaining that in quite detail why. Oh yeah, so yeah, Sylvain is right. It's like using hot plate for anything more complex than this is not really recommended. It's more for the show value in here. I would also put, I essentially put everything in a reflow oven. But the plate is nice if you need to rework something while it is hot and like reflown. This is good for high power, a lot of copper PCBs and stuff like that. So yeah, and these boards are also very simple. So the hot plate worked at least for the single one. It worked great. Let's see how it works for the quad. There we go. Let's adjust the camera again. Let's try to zoom in as much as we can. There we go. Now it is focusing on something in the background. Anyway, so it is heating up still. Let's see. We need to wait for this thing to heat up first. Then I can adjust it. And then I help it a little bit with the with the hot air rework station to help it from the other side. Because this is not really how it is meant to be reflown. So you are reflowing it by heating up the PCB and then it melting the pads. Usually you apply heat from either both sides or from top. Definitely in the reflow ovens, you apply it just from the top. So you heat up the components and the pads and the top side. So that's usually how you do it. With the heat plate, you do it the other way around. So you have to work through the whole PCB. Yeah, it's not ideal, I think. But it works. It works for what we are doing here. $160. Yeah, I think what is the temperature we set? 260, yeah. We're getting there. It's heating up. Smells nice and toasty. So the indicator here is actually like 20 degrees off. So it's actually 140, the actual temperature. So I measured it, and it's the thermostat on this thing is not very accurate. Well, it is probably very accurate on the where the thermal probe is, which is on the inside of the hot plate. So it is like inserted. There's heating elements inside the aluminium slab in here, and then the temperature probe is on the bottom. So I'm sure there is a gradient, and it seems to be about 20 degrees C from what I measured. So I had to crank it up to 260. No, 220. Okay, so we are getting close. So let me just zoom in onto the center here. And then, wrong way, there we go. 230. $240. $250. Yeah, I think we can put it on there. All right, let's try it. And plonk. And plonk. We need more light here. There we go. Let's get the heat gun going. Well, you should zoom. Focus, focus. There we go. And see how they suddenly melt. It's perfect. Just want to make sure that the Hyperram chips flow too. Okay. All right. That should be good enough. I should put it, I will put it on here. All right. Switch this off. Right, I'll be right back. So yeah, I'm getting the news that lunch is ready. So we should wrap it up soon. All right, so let's see how this looks. So at the first glance, this is looking great. I'm not sure you see it. Yeah, there you go. See? Wonderful, reflown, shiny balls. No shorts, no nothing. They are nicely squished in the right way. And that worked. Let's see if we can see something from this edge. It's a bit too high for the microscope. Yeah, it's a little bit too much. Yeah, but yeah, let's review this one. There we go. Let's see if I can focus. Yeah, there we go. Nice reflown boards. Easy peasy. Now let's see if they work. Need to solder the connectors on first, obviously. All right, so let's get some connectors. And then test Sylvain's code. Let's see if that works. That's 1, that's 2, that's 3, that's 4. I'm just checking if they are not missing legs or something, because there are some of those connectors that don't, because they're just cracked out of a longer strip. Okay, let's get the fume extractor running. Tack in 1, tack in 2. This was too warm. Come on. There we go. Flew out. There we go. There we go. Let's solder it up. 1, 2, 3. Come on. Come on, ground plane. Be nice. So you can see here how I'm doing jumpers too. Let's see, can we focus it better? Yeah. So my jumpers they're already connected by default between these two pads. So 3.3 volts is connected, and 1.8 would be, you would have to disconnect it with a scalpel or something here, and then create a solder blob on these two. Then you would connect the 1.8 volt voltage regulator. And this is for the other chips. This is not for these chips, so don't modify the 3.3 volt. Although I think they would run on 1.8 volts too. They're just not, you will not gain. So Jetak, yes, I'm still going, finishing the quad Hyperram modules. Just soldering on the connectors, and then we will be able to test them. So we are almost done for today. You should put these PCBs in a stick vise so that they don't fly around like this. I love stick vices. They are really nice for working on boards. If you have not seen them, this is how it looks like. This is a stick vise. There you go. That's a stick vise. Get 1, 2, 3 of them. Yeah, they are really awesome. No, they won't? What did I say? What did I say that you're referring to, Sylvain? Not sure. Oh, they won't. Oh, that the Hyperram chips will not work at 1.8 volts. Okay, okay. So they actually, you can't even run them on 1.8 volts. I see. That makes sense. Yeah, you need special chips for this. If you want the special version, send me an email. We can talk. Don't currently have plans to make them yet. All right, that's one. Let's do the second one. Wrong. This side. Don't burn your fingers. 1, 2. I'm very, very happy with those meanders on the PCB. They look so cool. It's like heating elements. Very, very cool. I like those. This is the first design that I did length matching, so I'm graduating here. And according to Sylvain, the matching worked out fairly well. Also, these chips are not... We are still in tolerance. That's what I think he said. We have margin. What he means that with it is the eye of the signal is well formed, and that the clock works well with that. He implemented the now already the DDR addressing or the interface for the Hyperram chips. So this is the cool thing. You can run it at single-ended or DDR, meaning you send data or receive data, or I think it is you send data on one edge and receive data on the other edge or something like that. Correct me if I'm wrong, Sylvain. It's always DDR. I see. I see. Okay. Almost done. Few more pins. There we go. Perfect. All right, so let's see. So this, I think, PC desktop. This got finished testing. It's so this was the single Hyperram one. Let's zoom out. It's very dark. Okay, so let's remove this, get some more light here going. Yeah, so we have the icebreaker. Now let's see if we can just plug it in. It's not shorting out at least because it's still on, so that's good. And now let's go, well, I actually should disconnect it for now and get the Verilog from Sylvain running. Temp, Hyperram, this is stuff he sent me. Make prog, programming the bit stream, and then I think Control MT is the correct thing to run. Let's see. It's doing something. Does it mean it works? I hope that's what it means. It's definitely running faster. Wow, is that the whole memory? Remove the second of the if true. Remove the second, switch runtime mode. Oh, okay. Do this. Wow, okay. So that's the full memory test. Cool. That's quick. That's very quick. Okay, and the second one. Uh-huh. Bam. Wow. Not sure if it tests everything. Okay. All right. Well, this is the thing that you sent me, Sylvain, so that's what I'm running. I don't know. As I said, I didn't really have much time to... but at least it's doing something. CS0, 1, 2, and 3, you can change the CS, the address at different chips. Okay, we can look at this. Yeah, there is a CS, and this is testing number 3. One, 2, 3, and 4. No, it should be 0, 1, and 2. Blah, 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 blah. Don't be an idiot, Peter. 2 and 3, so that would be, let's test 0. Working. Chip select 0. Now 1. After the H. Okay, yeah. I don't have the HDMI Pmod. We could, yeah, I can set it up for a future stream and then show that. But yeah, this is already very good. It's like it definitely shows that the connections seem to be working, I hope. All right, cool. So that's one. So yeah, that's good news. We have quad Hyperram modules that seem to be preliminary, at least, working. Wow, nice. And then this guy, number 1. Let's test that. Try not to get it. Okay, so if I disconnect this, yeah, it's different pattern on the front and zeros. Yep. And then let's test also number 2. Sweet. Thank you. 126, 186, 286. You're a 286 tech. Do you have a 286 at home? Are you using them? That was my first computer, was a 286. Awesome. That's perfect. I'm so very happy. Oh yeah, so welcome to the 286 club. That was my first computer too. Oh, very good. Glad to hear. Probably my 286 is somewhere in the basement of my parents. I should actually check and look for it. Alrighty, so now that we accomplished this great mission, we have now working quad Hyperrams. Looking cool. I will probably assemble the third one and put 2 of them, so do some more testing and checking, but if they work, I will put them up on the store, so you if any one of you guys needs 4X Hyperram, you can get it, and then we can move on to doing a manufacturing batch of the 4X, which will be nice. So yeah, let me just move this a little bit out of the way here. So yeah, that was it for today. It is lunchtime over here, and I hope you had fun and you enjoyed the short manufacturing assembly stream. Maybe it was a little bit informational. At least I showed you my process, how I do my prototyping, how I put things together. We did it with the heat plate, not the oven. The oven is a little bit difficult to bring in here because I usually use it outdoors so that the fumes don't accumulate in the room. So that was an exception with that hot plate. That's why the window is also open. So stay safe and use a vent and extract those fumes. Yeah, so That said, thank you very much for joining. I hope I will get a new stream running fairly soon. I will try to get back to some more regular schedule. I'm not sure what we will be working on next, but something interesting. Thank you for following 286 Tech, and thank you for joining the crew here. And so I would like to say a big thank you to the Patreons that are making these streams possible. Also check out the 1BitSquared store for the products that we make here. But definitely the shoutouts go to Edward Borden, Jerzy Hacker, Jordi Parky Rodriguez, and Sid Price, who chip in to pay for the gear for the cameras, and the streams wouldn't be possible without their help, and it's a great motivator to keep going and making some content. Also, as you see, join our Discord chat. We have a lot of very technical conversations and less technical conversations in there. If you have any questions about any of the stuff we make here, please feel free to ask. There's a lot of very skilled and knowledgeable people on our Discord, and we have some very interesting conversations there. All right, so that would be it. Thank you very much. And if you have been, thank you for watching. Bye.